use of digital workflow solutions, and the aim is to increase productivity. And how do we achieve that? We use several technological platforms available from Windmöller Hölscher. Windmöller Hölscher is a company that has three large production pillars. One of them is printing, in which I find myself as an employee, both flexo and gravure. And besides printing, one of the key production or manufacturing divisions is also extrusion. And we also have a large part of our company that deals with paper industry, paper making stacks, and complete paper sack making lines and filling. But again, we are focusing today on the printing part. Interesting is that if you talk about printing, we've been manufacturing printing machines for more than 100 years. As a matter of fact, our company is still a privately owned company and is existence in over 150 years, which we celebrated in 2019. And our drive has always been to innovate, not only in manufacturing machines, printing, for example, but also looking at other aspects and resulting in our innovation. To give you an idea, one of the best-selling printing machines, flexo printing machines called the Miraflex, has been in existence over 12 years. And we achieved all around worldwide sales of more than 700 of these printing units. So it's been quite a good contributor to our success in this market. Having excellent technology available in printing, we also asked ourselves, what do we do with all the information that we have from this machine? We know exactly what we need to do to give our customers excellent top-notch flexo printing capabilities, and we know what's going on in the machine. But since we did in 2016 the redesign of this Miraflex, we also considered, why not looking at all the information that comes from inspection equipment, which was up until then, 2016, still purchased in from third-party companies, and was, in our philosophy, not easy to integrate, combine information that we already possess coming from our machines, but also now integrating the information coming from quality inspection equipment. So in 2016, during the Drupa, we introduced a full suite of additional products, which we call Vision. And Vision allows us to integrate camera monitored quality inspection during production. Essentially, you look at the screen, and this is the human machine interface, essentially giving you access to control over the machine, the flow control, matrix camera for high quality zoom in quality supervision for production, line scan camera technology, which capture full live images during the whole print run in real time. And last but not least, using this technology to inspect the printed material. So in order for you to be able to check and rectify and make sure that what you produce is of high quality coming off the press. Not only is the print image being inspected for defects, but barcodes can be inspected as well, and color deviations can be tracked as well using the RGB LAB check monitoring. And last but not least, an important part is that you want to make sure that what you print is exactly what's on the digital prepress file. So we have a possibility to do a pre-flight check with our PDF check functionality built into our Vision platform. One of the key questions we get from our customers is why have you as a machine manufacturer, let's say, got into the manufacturing process of also inspection equipment? Well, the thing is that, like I said before, that was, let's say, an important piece of information quality-wise missing in our integration philosophy. And what we've aimed for, and Martijn mentioned also this before, that Press operators are aging. There's a skill issue that we need to address, our customers need to address. So if you provide these quality monitoring systems, they have to be intuitive to operate, so that they're fast and easy to set up, and that they reliably present the information coming from the inspected image. Having the inspected information available, so we analyze the defects, and we're able to also intelligently recognize some patterns to give or provide the operator with a quick determination where possibly the error or contamination is coming from, and help him to remedy and overcome this problem quickly, so it's back into production ASAP. And certainly important is that now offering this electronic surveillance platform together with our machines is that you only have one contact person. So whatever the need is, requirement for support, we do this 24/7 online, not only with a service hotline telephone, but also with remote support. And the big advantage is, since this is an integrated platform with the machine, there's only one source of contact. Ruby is a gem, and we consider that all the information accumulated and recorded during the production, on whether it's from the machine and its parameters like wet tension or dryer settings or viscosity, all key factors that influence print quality, now can be combined also with information coming from our inspection equipment. So we have a very strong amalgamation of information coming from the machine, but also from our inspection equipment. This is all bundled in our Ruby data collection system, and it allows you to conveniently track and supervise the print production from your office, and let's say take away some of the stress of the operators managing quality on press. This can be done remotely through web browser access, and of course combining all the information coming from the machine and from the inspection equipment, it allows you to cross-reference this information and do some root cause analysis. This is a combination of what we call Vision Check, which is the inspection equipment on press, and Ruby Check, which is the remote accessible evaluation tool for quality managers. Some use cases that we've done effectively, if you're able to record all this information, it allows you to trace your production, and also if there is, hopefully not, you produce good material, but if the case that something happens and you do have to sit down with customers and discuss a claim, with this traceability you can manage these claims on a purely analytical basis and an objective basis, using the central stored information, and that can be run down, let's say, for at least over 1 year time. So especially if you work in pharma or typical production areas like that, that traceability is given, and the traceability is based also on detailed individual role, produced roles, and total job reports, allowing you to go into detail and drill down in each production or each reel, actually giving you the defect information and the classification, and depending on whether you selected just print inspection, but it could also include color monitoring and also barcode. So all the key factors that are needed or required to do quality monitoring are actually available at the tip of your hands for the quality manager, also with the remote access. Like I said before, remote quality assessment, again, trying to liberate the operator and let him concentrate on producing good quality of press and evaluate quality later on a remote access station. And there you, this person that is responsible for quality management can review and analyze this information from the print process and do it remotely. So he doesn't have to be on press, but can do it from his office. And of course, we present this information, which is can be quite numerous, but we do this in a very user-friendly and intuitive way, using a so-called defect heat map, which is actually an image of the job that you've printed, and it shows you in different areas, in different color segments, where possible print defects have occurred. So it allows you a very easy and good access and a good overview where you, as a quality manager, may find the defects that have occurred very, very quickly. Now, having all this information available, and this is an example of a heat map. It shows you the reference image, which is collected for 100% print inspection, and it highlights in various colors where the printed defects have been detected and recorded. And depending on the color, it shows you the severity and the number of print defects. So it allows you very intuitively and quickly to drill into those areas which you may need to inspect as a quality manager and qualify and quantify for further action. Now, having all this information recorded and available, the question is, what do you do with it? In the end, it's if it is defective material, and this material is going to go down in downstream processing. So an additional step like lamination or another quality enhancing production step you want to avoid, making sure that your product that goes from step to step is free of defects. So this information will allow you to analyze and make sure that all the produced material is effectively good and enhances your next steps in your printing process. So, for example, once the defects are located, they are recorded, and they can be transmitted automatically to your post-pressing station, where they can be automatically detected and also removed. For which I have a small video which I would like to show you. It is just to illustrate how fast and easy defects can be detected and then effectively marked and removed. So, for instance, we start by printing, and during the printing process, we actually run our vision check, defect check system, and this will automatically scan for defects and record them while printing is in process. And then the entire job gets marked by an integrated inkjet marking system, so we know exactly where we are in the job, run meters and defects. So here's the reference for each defect recorded during the production run. And having this position marking, we can actually accurately tell where the defects have occurred and where they have to be removed. And this can be done per job and per reel, so you can drill down into high detail. And then even if you need to, you can analyze all the occurred defects individually, and then mark areas which need to be removed to make sure that you ensure that for the next process step 100% quality is delivered. So once all this information is marked, it comes down to the next station in the downstream processing system, for example, rewind the slitter station. And of course, the information from the job is loaded. The defect areas are marked, so we know exactly where they are. So effectively, only the area that needs to be trimmed out can be accurately removed, making sure that waste is actually reduced to a minimum. So a few key points: we can detect defects in real time with vision check, and we can analyze this information also remotely from the office for the quality manager, and we can effectively select the areas that need to be removed. So vision check and Ruby check will allow you to effectively use data obtained during the work process to make sure and ensure that 100% quality is delivered. Once you have all this information available, it will also allow you to do root cause analysis. So effectively you have removed the defects, but it's also interesting to see where has this defect come from. Yes, the vision check system has detected it, but now you can combine the status of the machine together with an overlay of the defects. So you're actually effectively overlaying all the machine parameters or selected machine parameters in relation to your printed defects, and then you can see and detect whether there's a relation in a certain change in, for example, viscosity or a web tension or a change in temperature, to see where this had an effect on the printing quality and a possible detection of your defects. Having this information available and doing this root cause analysis, it allows you to optimize your processes and in the end become more efficient. Again, very high detailed drill down is possible, not only for real but for jobs. Also, previous run jobs can be reopened and examined, also for traceability. Effectively, I can select several, as an operator, I can select several machine parameters to try and see if I can find a correlation and do this root cause analysis, helping me in the end to improve quality and efficiency. So a few key points that I would like to bring along. I mean, the integration of the WNH vision system and the print press parameters that we have available makes it intuitive, and the intelligent combination of this information makes it easy for the press operator to use. So it's intuitive and easy to set up and quick to use. And of course, we apply the standard WNH quality, which is well known for our manufacturing machines, in this case printing. But we also apply this to our inspection system. And the inspection data system, or the data that is being collected by the inspection system, can be stored in the WNH Ruby platform and for use for later quality assessments. And then this will lead to automated connectivity and help you control downstream processes and help you also in a more advanced way to do troubleshooting and come down to very quick and effective root cause analysis. We keep putting development efforts into analyzing information we get from not only our press but also from our inspection systems, so that we can even further assist and help the operators to make quick, determined decisions and come to the correction of any possible production hindrances that might occur. So there is more to come. Thank you for your attention. Something I'd like to mention, I mean, I have said already before, I mean, we're extremely proud to have won this EFTA award. And I recently learned that we have installed the 100th Ruby system in our customer portfolio all around the world. So quite a good